All right, so we're talking about batteries. So I'm looking at a 14.8V 35C 4000 mAh battery. What does all that mean?
Let's start with the type of battery first. These are called lithium polymer batteries. They are extremely powerful for their weight. I have one battery at 16,000 milliamp hours. That indicates the total capacity. The voltage I have is 25 volts. That's the amount of power, not capacity, but actual power in the battery. And the 35C in this case indicates how fast it can discharge. So that 16,000 milliamp battery can put out 1,000 amps if it was in a burst. We have to know a little bit about the chemistry and how these things work. They're sensitive in two ways. They're sensitive to high voltage when you're charging, and they're very sensitive to low voltage when you're discharging, so when you're flying around. Let's talk about the first part, the charging side of things. They're very sensitive. Their max is 4.2 volts per cell. The 14.8 in this case indicates to me it's a 4S battery, 4 lithium polymer cells in here. 4,000 milliamp hours. That's our total capacity in the battery. 14.8 volts. That's the voltage or power in the battery. And the 35C is how fast it can discharge at a particular moment in time. As we're charging them, each cell has to be charged up to, but not exceeding 4.2 volts. The charger that we use will actually control that for us. It's important to have a high quality charger because if you do charge them over that voltage, you do have a potential fire hazard. These batteries are different from most batteries. There is the main power, and then there is the charging tap. The main power is all 4 cells connected into one outlet. Each cell, however, also has an individual balancer for it, so we can access each cell individually as we're charging. Think of it as a level. We want to get up to here, but as we're charging, one cell may be charging faster than the other.
So the number of wires coming out of it here will tell you how many cells.
Correct. As this one hits 4.2 volts, it'll stop and it'll charge only the one that is lower to the point where they're both equal. So that's the charging side of it. The discharge side is where it becomes a little more arbitrary. When they're flying around on an aircraft, we don't monitor each cell. We're actually monitoring the voltage of the overall pack.
Power, yeah.
So we want to keep our voltage right around from going below 3.2 volts. The lower you bring it, the longer the flight you may have, but the lower the number of cycles that you can use this battery.
Gotcha.
It'll actually cause it to degrade the lower you go or the more often you bring it to a low voltage. So we try to avoid that.
So you've got a couple different batteries lined up here now. So if I've got let's say I have this quad right here, can I throw any one of these batteries on, or how do I know based on the zone I'm flying?
This probably isn't going to fly. The bigger quad, great for a small model like the Blade 180. We can get 10 minutes of flight out of here. We go to the larger aircraft, something along this size battery. This is a 6S. So we're putting out approximately 24 volts. This is a 5,000 milliamp hour. Normally on this larger aircraft, I run an 8,000 milliamp battery, and you can get about 30 minutes of flight time.
So if I took this then and put it on a much smaller quad, would I be able to fly this on something like a DJI Phantom or something?
Probably not a Phantom. I think we would be over the voltage. However, something like this, it's a 4-cell battery. It has 4,000 milliamp hours of capacity. probably more in the right sizing for this. So we really want to watch two factors on our aircraft. One is voltage and one is capacity. You never want to go over voltage on an aircraft. It's bad for the electronics if it wasn't designed for that in the beginning. The motors have a optimal voltage range. A higher kV motor typically runs a lower voltage battery. A lower kV motor typically runs a higher voltage battery.
What about the ESC? How does that fit into that?
The ESC, there's a couple of considerations we have to watch for. The first is how many cell count it's rated for. A lot of the lower end ESCs are a 4S, 2 to 4S. So the ESC, what we're doing with the ESC is converting the power from the battery into something that the motor can use. Notice in this particular example, 2 input wires, 3 output wires. You cannot directly connect these motors to a battery. It will not work. And what it's doing is converting the pure DC voltage into a sine wave 3-phase output that the motors can use. When we're looking at an ESC, there's a couple of things we're concerned with. The amperage rating. In this case, it's a 20 amp ESC, so it will, at its peak, put out 20 amps. Anything over that, you have a chance of overheating it. Your motors will have a rating based on the size of the motor and on the size of the prop. A bigger prop on a motor will draw more amps. Most of the good motor manufacturers will have a chart. You can look up your prop size, how much voltage, and then the typical draw at 50, 60, 70, and 100% throttle. And what we want to do is be a little bit above 100% throttle amperage for your ESC, so about 5 to 10% overrated. We're also looking for another piece in here. As I mentioned before, these are rated by the number of cells. Each cell is 3.7 volts nominal, up to 4.2 volts. So we need to find one that matches. On this aircraft, it's a 6S system. This is rated for 2 to 4. Wouldn't work. We'd overload it.
Blow it out.
Yeah, pretty much. So we want to be careful on those two figures. We want to know the number of cells it's rated for and the number of amps.